Welcome viewers. Today we are going to solve exercise 6.4 of class 8 mathematics, squares and square root. Question number 1. Find the square root of each of the following numbers by division method. In the previous exercises we have learned to find square root of a number by repeated subtraction method and prime factorization method. So let's learn finding of square root of a number by division method. Dealing this one. Firstly, we'll have to form pair of the number, that is form right hand to left hand. So with this approach we get 0 4 as a pair, 2 3 as a pair. Clear? Now we'll start the division method from left to right now. So we'll deal with 23 first. So 23 is the dividend for this step, and we have to decide the divisor. The divisor has to be a number whose square is equal to or less than this dividend. Clear? So in this case, 4 square is 16, less than 23. 5 square is 25, more than 23. So we'll have to take 16. Hence the divisor will be 4, and we'll get the quotient as 4. And 4 into 4, that is 4 square is equal to 16, will be here. Now we get the remainder as 7. Now in the next step we have to find the next dividend, which will be these two numbers, that is the next pair, or down. So we'll get 0 4 down, and we'll have 704 as new dividend. Now we have to decide divisor. Divisor in this step and henceforth will have two components. The left hand component of the divisor will be twice that of existing quotient. So 4 into 2, that is 8, will be the left hand component of the divisor. Clear? Now we have to find the right hand component of the divisor for this dividend. As this is a perfect square, we can get 4 in the unit position by either 2 into 2 or by 8 into 8, that is 64. So we need 7 in the 100 position, so we'll go with 8 and we'll multiply with 8, the same number which we have considered for the right hand component of this divisor. So we get here 8 into 8 64, 4, 6 balance, 8 into 8 64 plus 6 is 70, and we get remainder as 0, and hence this completes the division. And this 8 will be the right hand component of the quotient, and the number so obtained after completion of the division, that is with the remainder 0, is the square root of this number. Clear? So square root of 2304 will be equal to 48. Clear? Moving on to this question, same method, we'll form pair from right hand side. We'll deal 44 plus nearest possible with 6. We'll put 6 here and 36, and we'll have 8 as remainder. We'll get this pair down and we'll get 8 89, and the new divisor's right hand component will be 6 into 2, that is 12. The left hand component is 12. Now right hand component we have to find out. We want 9 in the unit position, possible 3 into 3 or 7 into 7. Since 8 we need 100%, we go with 7, and we'll have 49 and 4, 8 and 8. Remainder 0, and the right hand component of the quotient will be 7, and hence under root of 4489 will be equal to 67. Clear? So this will be, we'll take 34 first, and nearest will be 25, and here will be 5. This will be 9, and this will be 81 brought down, and the left hand component of the new divisor will be 5 into 2, that is 10. We want 1 here, so 1 will not suffice, we'll take 9, and we'll have remainder is 0, and the right hand component of the quotient would be 9. hence under root of 3481 will be equal to 59. Clear? So this one will start from right hand side, so this will be here, 5 will be left alone. We'll need 5 first, 2 here, and 22 4. So we'll have 1 here and 29 down. Now 22 to 4. So left hand component. Now we want 9 here. So this is with, we'll take 3 because 7 will be more. So 9 and this will be 12. Remainder is 0 and this will be 3. So under root of 529 will be equal to 23. Clear? So we'll deal 32 first. Closest number, which is square of 5, that is we get 25 here and 5 here, but 5 here. Now remainder 7, take this 49 down, 749, new dividend, and the left hand component is 5 into 2, 10. We can take 9, we can 7 into 7, 49, we'll take 7 here. Let's see, 7 into 7, 49, 0, 4, and this we get remainder as 0. So right hand component of the new quotient will be 7 and under root of this number will be equal to 57. Here we'll take 13 first and we'll take 3 here and we'll get 9 and we'll have 4. We'll get the 69 down and we'll have here 3 into 2, that is 6 as left hand component of the new divisor. New quotient 9 here, we can take 7 and let's see, 7 into 7, 49, we get 9 here and 42 plus 4, we get 46 and 0 is the remainder. So here we have 7 and under root of is equal to 37. From here 57, we have to get number, square number closest to it. We take 7 because we have 49 here and we'll have 8 here and 876 will be the new dividend, and here we'll get 7 into 2, 14. The right hand component, we want 6 here, 6 into 6, 36, just try with 6, we multiply with 6, 36, 3, 7 and we get remainder 0. So we have right hand component of this answer as 6. So we'll have under root of 5776 76. So this one we'll deal with 79 first and number closest to it is 64 and here we have got 8 and here also 8. So we have 5 here, 1. So this is the new number, which is, let's see, we have 18 to 16. So if I got 9 here, multiply 9 here because we want in the unit position 1. So this is 81 and 81, 1 here. So remainder is 0 and here the right hand component will be 9. So under root of 1 is equal to 89. Clear? So in this case we'll compare this way. 5, we have to get numbers smaller than this. So we'll have 2 here, 2 here, 2 into 2, 4. We'll have 1 here. We'll get the 76 down. We get new dividend, that is 176. Now we'll have 2 into 2, 4 on the left hand side, and we've got 6 here. So we can take 4 here and we'll get 4 into 4, 16 plus 1 here, 17. So we get remainder 0 and we get 4 here. So under root of 576 is equal to 24. Clear? So this one we'll deal 10 first, and we'll get 3 here and 3 here, we'll have 9 here and 124 remainder and the new dividend. So we'll have 3 into 2, 6 as the left hand component. Again, 4 you want, we can have 2 into 2, 4. Let's try. So 2 into 2, 4, and 2 into 6 is 12, and here we get 2. So remainder is 0, and hence we have under root of 4 is equal to 32. This forms pair, this forms pair. 31 we have to deal with. So we will take 5 here, 25. So 25 here, and we got 6 here, and the new dividend. The new divisor will get the first, the left hand component. 5 into 2 is 10. Now we can get, we have 6 here, so we'll get 6 into 6, 36. Put 6 here, multiply, we have got 36, and remainder is 0, and here we'll get 6. So under root of 3136 is equal to 56. Okay, here 0 0 will form pair, and we'll deal with 9 first. We'll put 3 here, and remainder will be 0. Get these zeros down. So we have got 0 and 3. So let's move on. We'll put 3 into 2, 6 here. Now only way we can get the 0 is put a 0 here, multiply with 0, we'll get all zeros. 16 into 0, 0 and 0, and here we'll get 0. So under root of 900 is equal to 30. Clear? Question number 2. Find the number of digits in the square root of each of the following numbers without any calculation. In division method we have seen, we form pair of the digits from right hand side to get the dividend, and every time we divide we get one digit in the quotient. So in this case we have got a single pair, so the quotient will be only in single digit. So in this case there will be only one digit, which will be the square root of this number. In this case, from right hand side we get one pair and we get a low number here, but we'll start dividing from left hand side. So first we'll divide 1, then we'll get a digit in the quotient. Again we'll get a new dividend when you get this number 44 down, and again we divide, and when you divide we get the second digit in the quotient. So in this case we'll have 2 digits. Here also 2 pairs, and hence we'll have 2 digits. We'll divide twice, and every time we'll divide we'll get one digit in the quotient, hence the square root of this number will have 2 digits. Similarly, in this case we have two pairs and one single digit, so we'll divide thrice, and every time we divide we'll get one digit in the quotient, so we'll have the answer in 3 digits. Similarly, we have got 3 pairs here, and hence we'll have 3 digits. Clear? Question number 3. Find the square root of the following decimal numbers. So for decimal numbers, we deal the left hand component separately and the right hand component separately. We'll put bar, that is we form pair from right to left of these numbers, that is on the left hand side of the decimal, and from left to right we form pair for the numbers on the right hand side of the decimal. So let's get started. In this case we'll first deal with 2, and so we'll get 1 here and 1 here, and we'll have 1, balance 1, and we'll put decimal here, and we'll, as usual, we'll double the left hand component of the divisor, so we'll get 2 here and get 556 down, and we'll take 6, multiply 6, 36, and 12 plus 3, 15, remainder 0, and we'll have 6 here. So our answer is 1.6. Clear? Same way, we'll do the 7 first. We'll have a 4 here and 2 here and a 2 here. We'll have balance 3. We'll get 29 down, and we'll put a decimal here. We'll have 2 into 2, 4, and we'll put 7 here, we'll multiply with 7 and we'll have 9 and 4, 0. So we'll have answer as 2.7. Clear? This one will form pair this way, pair this way. Okay. So we'll have 7 here and 7 square 49. Remainder 2. Decimal, we'll put decimal here. Get the 84 down. We'll have 14 here and we'll multiply with 2. So we'll get 4 and 0. And we'll have the answer as 7.2. Here. This one we'll do 42 plus, we'll put 36 here and we'll have 6 here, 6 here. Put the decimal. Okay, we'll have 6 and we'll put decimal here and get 25 down. 6 into 2, 12. And we'll put 5, we'll multiply with 5. So we'll have 5 here, 25, 2 here and 6 here, 0. So we'll have 6.5 as answer. In this case 31, so we'll have 25 here and 5 here. So balance, we have 6 and here 5. We'll get 36 down and put decimal here, and here we'll have 5 into 2, 10. So we'll have 6 into 6, 36. So we'll have 6 here and multiply with 6. So we'll 36, 6 here, 3, and we'll have 6 and remainder 0. So we'll have answer as 5.6. Clear? Question number 4. Find the least number which must be subtracted from each of the following numbers so as to get a perfect square. Also find the square root of the perfect square so obtained. So let's see by division method what is the remainder. If we subtract the remainder from this number, we'll get a perfect square. So here we'll have 2 and 2, and here will be 2 into 2, 4. So we'll have 0 and get this pair down, 0, 2. Now here we'll have 2 into 2, 4. Now if we subtract 2 from this, we'll get 0. And so in that case, we'll put a 0 here and we'll get 0 here, and remainder will be 0. So the number which will be the smallest one, if subtracted from 402, will be 2, and the new number will be 400, and the square root of 400 will be 20. Clear? Now this one, we'll get a 4 here, 16, we'll get a 4 here, and we'll have 3, 18, 9. Now 4 into 2, 8. So if we take 4, that seems to be closest. So 4 into 4, 16, 32 plus 1, 33. This seems the closest one. So we'll get a 3 here and we'll get a 5 here. This is the balance. And if we subtract 53 from this number, we'll get, of course 4 will be here, we'll get square root of the new number as 44. So we'll subtract 53 from this number, which will be the smallest number to be subtracted, and we'll get the square root of the new number obtained as 44. Clear? This one, we'll do 32 plus first. So here we'll have 5 and here 25 and will be 5. So we'll have 750. 550 down, and we'll have 10 here. So nearest number close to 750, we want 7 here. So if we multiply by 7, so we'll get here 49, 7. Yes, so we'll have 749 and remainder will be 1. So if we subtract 1 from this, we'll get the new number, and the square root of the new number will be 57. Okay? Moving on to this one, we'll deal 8 first. So we'll have 2 here and 2 here. We'll have 4 here and 4, 25. Now 4 here, and if we one closest number, so let's try with, it seems to be 8 if we take. So let's see, 8 into 8, 64, we get 4 and 6 balance, 38. So we have balance as 1 here and 4. So we get balance as 41, and if we take 9, yeah, it will be more. So 41, if we subtract 41 from 825, it will become a perfect square, and we will have square root of that number as 28. Clear? This one will have 0, 0 as pair, 40 as pair. So we'll get 36 here, and we'll have put 6 here, and 6, and we'll have 4, and get these two 0 down. Here we'll have 12. So we want 4 here, so if we put 4 here, so we'll have 3 here, because if we put 4, we'll get more than 400. So let's see, this will be 9, and this will be 6, and this will be 3, and we'll have 1 here balance, and this will be 31. So if we subtract 31 from 4000, we'll have a perfect square, and square root of that number will be 63. Clear? Question number 5. Find the least number which must be added to each of the following numbers so as to get a perfect square. Also find square root of the perfect square so obtained. So now we have to add the minimum possible number so that this number becomes a perfect square, and that is going to be the remainder when you go by division method. So let's start. We have 5, so 2, 2, 4. Okay, 25 down, 125. So here we have 4. Now we can take 3 here, so we get 3 into 3, 9, 12. So 129 is the closest number to 125. That means if we add 129 minus 125, that is 4, to this 125, we'll get remainder as 0. So the minimum possible number to make this number, if added, a perfect square, is 4, and square root of the number so often will be 23. Clear? So let's move on to this. We'll take 16 here, we'll have 4, 1 balance, and we'll get this 150, and we'll have 4 into 2, 8. So in that case, we'll get close to, if we take 3, it will be 2, 4. So we'll take 2 here. So 2 we'll get here, 4 and 16. Just a bit more than 150. Hence, if we add 14 to this, we'll get a perfect square. This will be 164, and we'll get remainder as 0. So we'll have to add 14 to 1750 to make it a perfect square, and that number square root will be 42. Clear? So this we take, we'll take 2 here, so 1, 1, and here also 1. So we'll have 152, and 2 into 1, 2. So let's take, we have to take, if we take 6, we have 26. So that's 36 and 156. And if we add 4 to this, we'll have remainder 0, and 16 will be the square root of the new number obtained. So we'll have to add 4 to 252 to make it a perfect square, and square root of the new number obtained will be 16. Clear? Moving on to this question, we'll have 16 here, and have 4 here, and a 4 here. So we'll have 2 and get this 25 down. This will be 8. And we'll take 3. And if we take 3, we'll have this as 9 and 24. 249, closest one possible. So we'll have, if we add 24 to this will make 249. Hence, we'll have to add 24 to this number 1825 to make it as a perfect square, and square root of the number obtained will be 43. Clear? Moving on to this one, we'll take 64 plus first, so we'll have 8 square 64. No, this will be 0. We'll get this 12 down, and here we'll have 16. Now, if we take 0, this will make 160 multiplied by 0 will be 0, which will be less than 12. So we'll go with 1, and this is going to be 161. So if we subtract 12 from 161, we'll get 9, and we'll have 4 and 1. That is, if we add 149 to 12, we'll get 161, and that will make this a perfect square with 1 here. So we'll have to add 149 to 6412 to make it a perfect square, and square root of the number obtained will be 81. Clear? Question number 6. Find the length of side of a square whose area is 441 meters square. So let the length be x. So area will be x square, and this area is equal to 441. Now we have to find value of x. We'll move this 2 here. That is, we'll take this in inverse operation. So x is equal to under root 441. So let's apply the division method. We'll have 2 here and have 2 here. So we'll have 4 here, 0 will get 41 here. We'll have 4, so we'll have 1 here. We'll have 21, and hence we'll have 41 and remainder as 0. So we have got the value of x, that is equal to 21 meter. Clear? So length of side of the square is 21 meters. Question number 7. In a right angle triangle ABC, angle B is 90 degree, and the sides given are AB is equal to 6 centimeters. So this is 6 centimeters, and BC is equal to 8 centimeters. And we have to find the value of AC in this case. So this is part A, this is 7A in fact. So we have to find the value of this side, that is AC. This is right angle triangle, so this is hypotenuse. We'll apply Pythagoras theorem. So we'll get the value of AC. In this form, AC square is equal to AB square plus BC square. So we have the value of AB as 6, so this will be 6 square, plus this is as 8, so this will be 8 square. We'll have 36 plus 64 is equal to 100. So AC will be equal to under root of 100, that equals to 10 centimeters. So this will be 10 centimeters. Clear? Now the second part, so 7b, it is stated that if AC is 13 centimeters, so in this case for B we'll take this AC is equal to 13 centimeters. So we'll put AC is equal to 13 centimeters and BC is 5 centimeters. So straight away we'll apply Pythagoras theorem. So 13 square will be equal to BC, that is 5 square plus AB square. So we'll have 169 minus 25 is equal to AB square. Hence AB will be equal to, we'll get 144 in this case, and inverse operation, so under root. So AB will be equal to under root 144, that is 12. This is centimeter. So length of AB in this case will be 12 centimeter. Clear? Number 8. A gardener has 1000 plants. He wants to plant these in such a way that the number of rows and number of columns remain the same. Find the minimum number of plants he needs more for this. He has got 1000 plants. Number of rows and column has to be same. Hence, it has to be in a plantation has to be in a square pattern. So we have to find a perfect square which is just more than 1000, because it has been stated that how many more plants he needs. So we'll try to find this by division method. We get 3 here, 3 here will be 9, and we'll have 1 and 0. Here will be 6. So if we take 1, we'll get 61. Let's take 2. So we'll have 4, and so this is the number which is nearest to 100. So if he managed to get another 24 plants, we'll have a perfect square, and he can do the plantation with 32 rows and 32 columns. So the minimum number of plants he require over and above 1000 is 24 plants. Clear? Question number 9. There are 500 children in a school. For a pretty little, they have to stand in such a manner that number of rows is equal to number of columns. How many children would be left out of this arrangement? So in this case, few children will be left out. So let's see. If they stand with number of rows and column equal, that means in a square pattern, how many children will be left out? So 500 we have got. We get 2 here and 4 here, 2 here and 100. So we'll have 4 here. So if we take 3 will be more, so we'll take 2. So we'll have 4 and 8. Hence, if we subtract, this will have 16 as remainder. So these are the extra children who won't be able to stand if number of columns and the rows are equal. So 16 children will be left out. Clear?